scientific notation, the explanation for scientific notation is that it's used to write very large or very small numbers. It condenses it. So instead of writing this huge number here, we can just simply say it's 1 times 10 to the 15th. Now normally we don't see that kind of sign in there, we'll just see the x. So 1 times 10 to the 15th. Or this really small number here, we would just simply state it as 5 times 10 to the negative 11th. Scientific notation is written in this form, so it's got a number times 10 to some power. Very important that you know that A, okay, because I said it was going to be written in A times 10 to the nth power. This A has to fall between 1 and 10. It cannot be anything, it's got to be 1 or anything smaller than 10, so it cannot be 10. Numbers here, and let's decide whether or not these are written in scientific notation. So we're going to check out this first number. We're going to say, does it fall between 1 and 9 or 1 and 10? And it does. And it does have something written to times 10 to the power, so this is a yes. The second one, does this number 52 fall between 1 and 10? No, so this is not scientific notation. And this last one, does this number fall between 1 and 10? And the answer is no, so it is not scientific notation either. So to write a number in scientific notation, one of the things we're going to do is use a positive exponent to write a number that's greater than 10. So we'll use a positive exponent to write a number that's greater than 10. And we'll use a negative exponent to write a number that's between 0 and 1, or those decimals. So let's practice writing some things in scientific notation. The first thing I want you guys to do is, when you look at the number, I want you to decide where you would place the decimal so that the number would fall between 1 and 10. If I look here, I would have to put the decimal right here. That way I'd have a 2 out here in front, and it would fall between 1 and 10. So that means I'm going to start out by writing 2.67 times 10 to some power. I'm going to put this as a box here because I want you guys to think logically about this and not just memorize some way of coming up with your answer. I'm going to first figure out what the number is. 1, 2, 3, 4, 5. We've moved our decimal place 5 times because there was a decimal right here, even though you can't see it. So I know this is 5, but is it 5 to the is it a positive 5 or a negative 5? Well, because this is a really large number, we would say it's a positive number, a positive exponent, because we want to make this 2 as large as it once was. So in order to do that, we'd have to multiply by a big number, and so we'd have a positive exponent written there. Continuing on with some more of these types of problems. Again, my method is going to be to figure out where we're going to place this decimal so that we have a number between 1 and 10. I'm going to place the decimal right here between the 4 and the 6 because that means I'd have 4.6, and 4.6 is between 1 and 10. So I'll write that number, 4.6205. Now I don't have to write any of the zeros that follow, just all the numbers up until I get just zeros left over. I move the decimal 1, 2, 3, 4, 5, 6, 7 places, so I know it needs a 7. But is it a positive 7 or a negative 7? That's the next question you have to ask yourself. Because you want to make this 4.6205 46 million, we need this to be a positive exponent, so we're multiplying it by a really, really large number so it can become large again. Moving on to the next one, we're going to figure out where we need to place the decimal so that we have a number between 1 and 10. And if I place my decimal right here, I have a number between 1 and 10. It's 3.25 times 10 to some power. I'd be moving this 1, 2, 3, 4, 5 places. So I'll put a 5 here. I still need to decide if this is positive or negative. In this case, I'm deciding that it's negative because this 3, in order to make it really, really small, I would have to multiply by a very small number, and this would be like having that fraction 1 over 100,000. So I'd be multiplying by a decimal, which would make it very, very small. In the next problem, The last one here, we're going to say that we're going to put the negative, or figure out where we're going to place the decimal so that we have a number between 1 and 10. We're not going to put it here where a lot of people want to put it here because that's 0.9 and that's not even 1. It has to fall between 1 and 10, so the decimal is actually going to fall behind the 9. So we're going to put 9.0, or you could just simply leave it 9 times 10 to some power. Either one of these answers are okay. You can have 9.0 or just 9 times 10 to some power. How many places do we move it? Well, we're moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I have a 9, but I know that it's going to be negative because I need to make this 9 really, really small. So I need to multiply it by a very small number. Continuing on with scientific notation, we're going to talk about how to write it in standard notation. Again, you can memorize this, but I don't recommend you memorizing it. I like you to think about this logically. So if you have a positive exponent, we're going to move our decimal place to the right. The reason why we're doing that is so that we can create a larger number. Okay, because if you have a positive exponent, you're multiplying by a very large number. A negative exponent, you're going to move your decimal to the left. But the reason why you're moving it to the left is because you're creating a smaller number, because a negative exponent is multiplying by a small number. And so we have 10 to the 7th power. So since this is a really, really big number we're multiplying by, we want to make our 3.2 really, really big. So we're going to move it 1, 2, 3, 4, 5, 6, 7 places to the right. So I get 3, 2, 0. I'm filling in all these with zeros. So I end up having 6 zeros here. 1, 2, 3, 4, 5, 6 zeros. On this next problem, I have the exponent of 4. So I know that is a large number. It just happens to be 10,000. So I know I'm going to be multiplying 5.07 times 10,000, which would mean you're moving your decimal to the right because you're making your number larger. So we'll move it 4 places, 1, 2, 3, 4. So that means I have a couple zeros to fill in here. So I have 50700, so 50,700. This last problem, I have a negative exponent, which is saying I'm multiplying by something very small. So I need to make this number smaller, so I'm going to move it 4 places to the left. 1, 2, 3, 4 places. 1, 2, 3 zeros then. So I have 0.00056. These are all written in standard notation now. Alright, in this next problem I'm asked to order these from least to greatest. The easiest way we're going to find to do this is just to put these in standard form first and then go back. So when we put these in standard form, we're going to notice that we have a positive exponent here. So I'm going to say that I'm multiplying by a large number, so I want to make this number larger. So in order to do that, I would be moving it to the right. So that actually makes this number be 630. This one again is a positive exponent, so it's making it large, so I'll be moving it to the right, which would be 60,300. And then the next problem here, this one already is in standard form. And then the last one, I'd be moving it 3 places to the right because I want to multiplying by a larger number of 1,000. So I have 63,100. Putting these in order then, this would be the smallest, the second smallest, the third smallest, and then the fourth smallest. So when you'd write your answer, you would go ahead and say that 0.0063 times 10 to the 5th is the smallest. The next smallest would be 6,103. The next one would be 6.03 times 10 to the 4th. The next one would be 63.1 times 10 to the 3rd. Now for the last types of problems, what we're going to look at is how we deal with these parentheses and do they really matter. And in this problem, I want you guys to know that because everything's being multiplied together, the parentheses really do not matter. We can multiply whatever we want in whatever order we want. It doesn't matter if there's parentheses there to begin with. That is very different than having something like this, where parentheses do matter, because normally we do multiplication and then addition first, and here I'm saying we have to do addition first. Well, here when you have all multiplication, it does not matter the order in which you create that multiplication. So while some of you are going to think we need to distribute to both of those, that's not the case because it's not a plus sign between them. It's not being distributed to both of them. It's really just saying you have 2.5 times 6 times 10 to the third, and with the associative property, we can actually move those parentheses in whatever order we want. So I'm not even going to put the parentheses there. I just want you guys to know that there does not need to be parentheses here. We're going to go ahead and multiply then 2.5 times 6. 2.5 times 6 is 15 because I'd be moving that over one spot, which would give me 15.0. So I'd have 15.0 times 10 to the third. The problem with this is now it is not in scientific notation, and a lot of times I want it in scientific notation. My suggestion is go ahead and change it to standard form first. Move this over 3 spots to the right because we will need to make our number bigger, which gives us 15,000. That will allow you then to change it into scientific notation, looking for that spot where that decimal would need to be placed, which would be between the 1 and the 5. And then you would be able to put that in scientific notation without trying to figure out or come up with some rule. A lot of people want to come up with some rule and then they have to memorize that rule. In this case, we're just thinking about it logically, so there is no rules to follow. We're just using our brains to think about it. So we want 1.5, and that means we would have moved our decimal over 4 spots, and it would be a positive 4 that we want because we want our 1.5 to get really, really large. We really are just saying 0.4 times 2 times 10 to the negative 9th. Well, 0.4 times 2 is 0.8 times 10 to the negative 9th. This is not in scientific notation. So let's change it into standard notation first. So I'd have 0.00000. I have to move that decimal over 9 spots, so I have 9 zeros. I've got 3, 4, 5, 6, 7, 8, 9 zeros now. 8. That's the standard form of this, or standard notation. I shouldn't say standard form. Now to put it in scientific notation, I know that my decimal needs to be right here behind the 8, so the number is between 1 and 10. So I have 8 times 10 to the negative 10th power because I need my 8 to be really, really small. The last problem I'm going to squeeze in here is 48 times 10 to the negative 4th. 48 times 10 to the negative 4th is 1234.0048. And then put that in standard or in scientific notation, I'd have 4.8 times 10 to the negative 3rd. I need that decimal right there, and I need to make it smaller.